All right. So we're gonna do 8.1 and then maybe 1.5, and then we'll do some practice problems. Okay. So first do our definitions. So the set of numbers consisting of this is for integers. Now let me see here. Get the proper definition up. Whole numbers. And their opposites. Two S's? No. Numbers and opposites is called the integers, or the set of integers. The way I remember them is just all the whole numbers and all the negative whole numbers. That's it, including 0. So 1, 2, 3, 4 forever. -1, -2, -3 forever. Both directions, right? No fractions. The way you would write it, if you use your Z notation for integers, they put a little fancy Z. It's like a bold Z, I guess. I can't draw it, but basically you have 0, 1, 2, 3 forever, and the other direction, -1, -2 forever. Okay, it's both directions. You put little braces to denote a set. So whenever you see those, it's a set, meaning just a list of items. In this case, the set is integers, just numbers. Okay. A variable is a symbol, generally a letter of the alphabet. You write that prettier. Although, if you go far in math, we start using Greek letters and then Hebrew letters. But in algebra, you stick to English for the most part. That is used to represent an unknown number or any one of several numbers. Should be towards the front, I think. Well, actually, mine's all out of order. But look for chapter 8 on your workbook. Okay. So what is a rational number? Do you remember? It contains the integers, for sure. But usually when we hear rational, we think of a specific type. So they're written in the form of A over B where A and B are integers. So the form A over B, where A comma B are integers. Maybe I'll write that down here. Are integers. And B cannot be 0, obviously. Another way to think about it, if you look at calculators, let me zoom in a bit. So basically, decimals that terminate, that don't keep going forever, those are rationals. Like 0.25, that is a rational number. Okay. So let's put that in the proper definition. So a rational number is a number that can be written in decimal form as a terminating decimal or as an I see. No, this is better. As an infinitely repeating decimal. So if it does repeat, I mean, if it does go on forever, it has to be the same number. It can't be like changing. Like, for example, 0.33 forever is okay, but pi would not be okay because that just keeps changing. Does that make sense? The difference between
This is as a
terminating. Say terminating decimal or as an infinitely repeating decimal. So for example, terminating would be like 0.25. Infinitely repeating would be like 1/3, 0.33 forever. Okay, those would both be rational numbers. Those are fine. Now, all of those can be written as a fraction. So if you can, then you're good. Numbers that cannot be written as fractions with integer numerators and denominators are called irrationals. So these are the weird numbers. Weird numbers like square root 2, pi, the number e. All those are not rational. Okay. Irrational numbers. Okay. Okay. We're just doing definitions for a second. Now, graphing numbers on a number line is no big deal, I hope. If I put 0 here, the number 0 would just be a point. So when you're graphing these, just put a point. Okay. if 1 is right there and 2 is here, 1.5 would be there. So this is 0, 1.5. I'm drawing the arrow just because I don't want to jam it in here. Technically, you should put it right in the middle. I just don't have space. Okay. So just put dots, that's it. 3/4, what is that? What is this as a decimal? Yeah, negative 0.75, is that beyond -1? Or is it right before?
No, that's right forward.
This would be right here, right? About. So no big deal. So if you graph this on your homework or on paper, it's shouldn't be a problem, right? Okay. Okay. So number 5 on the next page. Oh, I forgot there's a back part. Dang it. Okay. So try graphing this guy. Do you have any issues graphing it? What is 5/4 as a decimal? It's basically 1 1/4, right? So somewhere around here. Negative 2.5 is basically -2.5. So that would be more negative than -2. So the bigger negative number, the more to the left, right? One further in the left direction. So if it's really big negative, I'm gonna be way out here. Okay. Which is thought of as smaller. That's kind of weird. Obviously, the bigger number, just go to the right. Okay. Anyway. You remember what these symbols mean? I'll do the hard one for you. This one less than or greater than?
Greater.
Less than. It's okay. I'm always paranoid too. And shit. Is it the other way? Get dyslexic when I look at it. It's like, but then I just picture it like, okay, if there was a number here in front of it, it'd be pointing to the smaller one, right? It's this less than something else. Okay.
That one greater than. Yeah.
This one?
No.
Oh, the next one?
Yeah, the next one is that. Greater than. Yeah, greater than.
This one is the same direction. It'll be less than or equal to. That's what you meant, right? But yeah, I hear what you're thinking. Right, that little line underneath means it could be equal or below, right? Less than or equal. So this guy has to be greater. And this guy is the same thing with the equal part. This guy is obviously not. Whenever you see a line through a symbol, any of these symbols is just not. So this would be not equal. So if you put a line through less than, you'd say not less than. If you ever saw that. Okay. All right. If you're ever in doubt, and you see some symbol, right? 5, it's always pointing to the smaller one. The arrow points at the smaller one no matter what. So at that point, you figure, okay, what is the proper English? This is smaller, right? So 5 less than 7. So whenever you're in doubt, just write it. And that's okay if you forget. Anyway. So I wrote it this way. It's the same statement, but I'm saying it in a different way. This would be 7 is greater than 5 because it's still pointing at the smaller one. If it's pointing at something that is not smaller, then it's a false statement. Like it could be written like this, right? If you were to see that, like 5 is greater than 7, it's not true. So if it ever comes up, just say false. Okay. Anyway, absolute value. Do you remember what that means? I think the easiest way to think about it is you put in a number. If you take the absolute value, it's just the distance from 0. Okay. So the official definition is the absolute value of a real number is its distance from 0 on a number line. Note that the absolute value of a real number is never negative. If you, its distance from 0 on a number line. So this part, I ran out of space, so it's right here. Sorry, it's a little messy. Oh, up top? Here? Okay. Yeah, never negative. Because it's a distance, so it doesn't make sense to say I'm negative 10 feet from you. It's weird. Okay. But the way to think about it, if you see the bars, whatever comes out of that has to be positive, no matter what. So just if it's already positive, cool. That's the answer. If it's negative, then switch it. Okay. I think we'll do some in a second. But basically, if you saw absolute value of 2, these little bars, then the answer is 2. If you saw a negative in there, it's still 2. So just change it to positive. And if you forget why, well, it's the distance. How far away from 0? We'll look at the number line. 2 is right there. So it's 1, 2 numbers away. Negative 2 is 1, 2 numbers away. That's all it means. Okay, pretty straightforward. Does that make sense? Okay, so now let's see if we understand the concepts. Is number 1 true? What do you think? On a number line, smaller numbers are always to the left of larger numbers.
Yeah.
Yeah. Okay, what about number 2? Absolute value of a negative number is a positive number.
It's true.
Yeah, it's always positive, right? In other words, it's never negative, so it has to be. All whole numbers are also integers. Yeah, because what are integers?
The opposite sex.
Is both, right? The opposite and the regular ones. So if the whole numbers are in there, then yeah, of course. Okay. Does that make sense? Is there any question on the introduction? Is that okay? All right. So let's do some problems. You guys cool on this page? All right. Number 4, is 0 a positive number? Yeah. False. It's neither, right? Zero is neither positive or negative. Okay. All right, try number 5 and 6. Light checks. It's not too bad, right? So far. So what you guys got for 5? Okay. The whole numbers are easy. -1/3, is that below -1 or above? Yeah, it should be about there, right? You guys have any issues plotting points? Any problems? Now's the time to ask if there's any issues. Okay. 7 and 8, you need to understand the definition for whole numbers and rational numbers. Having this set of numbers, set A, see how they have the brace? That's a set. A set can be anything. It could be a set of types of chairs, types of just names, doesn't matter. In this case, it's a set of numbers, different types of numbers. List of numbers. Which one of them are whole numbers? So put all the whole numbers under here. And all the rational here. So for 7, did you guys get 0, 4, 8? Did I miss any? Let's see. That's 5.9. It's not a comma. Right? 4, 8, 0 are the only whole numbers that I see. They are also integers. The negatives are not whole numbers, those are integers, right? They're negative whole numbers, I guess. Rational are for sure all the fractions, right? But also you can write any whole number as a fraction, technically. I could write 4/1, right? You see what I'm saying? Yeah. Pretty much almost every number here is a rational, except the ones that are non-repeating decimals. For example, √6, if you punch it on your calculator, it goes on forever and doesn't repeat. It's kind of like random. Same thing with √5 and √11. So these are irrational. 5.9 is a terminating decimal. If you look at the definition, we said if it terminates or if it repeats, we're good.
So this irrational numbers.
Yeah, we can't. So everything except the square roots would be rational. You guys see that? Okay. Do you see why whole numbers are also rational? Because it can be, but what was the definition? Go back. Math is all about definitions, whether we realize it or not. The form of A over B, where A and B are integers. So I can choose an A to be 4, right? And choose B to be 1. So that would fit the definition of rational. I wouldn't break the requirement. If that's true, then 4 over 1 is equal to 4. So by definition, it is irrational. Okay. That's the logic. Does that make sense? Make more sense? So that I can write all the whole numbers like this. It's weird, but it's true.
There a number that can be irrational?
Yeah, all the square roots, that all the ones that don't simplify are irrational. So any number that is non-repeating on your calculator, but if it's like pi, for example, is an irrational.
Storing different groups.
Yeah, it has to be the same.
It's the same root, that's rational.
Yes. Like if you plug in 1/3 on your calculator, you get nothing but 3s, right? That's fine. That is by definition rational. But if it changes, and it keeps changing, then it's irrational. Anyway. All right, so let's look at these statements. That's what these are. Is this statement true?
Yes.
Is 0 equal to -0?
No, that's false, there is no negative zero. The same thing, so. Really true. Negative zero doesn't.
Yeah, I mean it's kind of weird, right? If we think of it as -1 times 0, it is in fact 0, right? The negative doesn't do anything to it. So writing that minus is pointless, but that doesn't mean you couldn't do it. You can. It's just weird. This is still 0.
That's just true.
Yeah, so it is true. In this case. For example, if I said, is 0 equal to 2 times 0? That is a true statement, right? Or is 0 equal to -1 times 0? It's still true. So this is basically a -1 in front. I thought it was false for a second too. That wait a minute. The minus can't do anything to 0, so it's fine. What about 10?
That's true.
What happens to the -8? Yeah, so if we do the work, absolute value makes it positive. Now we look at it and say, okay, is the one it's pointing at the smaller one? And it is, right? Since it's pointing at the smaller one, this is a true statement. 8 is greater than or equal to 4. We're good.
But it's negative, so.
It's true. Once we get rid of that, once we do the absolute value, we're good.
What do you call it? Absolute value?
Yeah, the little bars are called absolute value. So whatever's inside will come out as a positive. If it's already positive, then just take the bars off.
So you just take the bottom.
Yeah. That's what absolute value does. changes to positive. But the definition said it is the distance from zero. So how far away is -8 from zero? It is 8 units away. Okay. All right. You guys cool on number 10? Alrighty. The Alvin is a manned deep ocean research submersible that has explored the wreck of the Titanic. That's kind of bad time to talk about this problem. The operating depth of the Alvin is 4,500 meters below sea level. Should have used that PS5 controller instead of the Logitech. All right. So if the operating depth is 4,500 meters below sea level,
So it's negative.
yeah, we should think of it as a negative distance. So we're going down. Meters. Oh. Okay. The Mariana Trench is the deepest known location on the Earth's ocean floor. The deepest known part of the Mariana Trench is approximately 11 kilometers below sea level. So same deal, right? Yeah, that's all they want. I want you to think about this as a type of unit. Okay. So negative kilometers. All right. All right, try these next problems on your own. 1 through, let's see here. How many are there? One through 6. What's up?
I don't think I helped. You didn't.
Yeah, no. Here. Take these. 1 through 6, I said, right? Those are yours. So
I put the, I email you about the, 6.3. I didn't understand that one. And you
Okay.
only put a grade in there.
6.3,
6.3.
is it closed? Still open. Okay, yeah, I'll give you some more time. I'll extend to 6.3. Okay, no worries. I'll be changing the dates on 6.3 and the stuff we talked about today. I'll adjust those.
Would it be a rational number if it repeats the same number if it's a decimal, if it's just 33.
If it's just the same, it's irrational.
It's rational?
Yeah, if it's the same number repeating,
Okay. Yeah, that's not.
rational. Yeah, whatever we go over today, I'm gonna adjust for Monday night. Okay. There should be 8.1 and 1.5. If multiple apply, circle multiple. What's up, man? No, I should switch to here, but I'll try it. I'll switch in a little bit.
Because I always use Dante.
Is Dante?
Yeah.
That's this guy?
Yes.
Okay. All right, I'll try it out right now. Thanks, man. So number one, what'd you guys choose? Yeah, for sure. For sure is an integer, but it's also rational, right? So it's both. So B and C would be the answer. Yeah, both apply. Number two, we cannot see from here. Yeah, looks like it. Unless you can write that as a fraction somehow. That was the other part of the definition, right? If you write the decimal, if it repeats, you can write it as a fraction, or if it's terminal. It's not terminal. Looks like it's not repeating either. I want to say irrational. No, I want to say irrational.
Okay, I'm going to scared.
Yeah. Based on the definition, right? So we know the definitions, we're good. We're safe.
What was number 2?
Irrational. Okay. Number 3. Yeah. The more negatives are always smaller than positive. And if it's very negative, then that's very small. That's how we should think about it. So here, obviously, right? Negative is always less than positive. So it has to be true. That one's pretty easy, right? Yeah. I mean, it's a fraction. So we're good. By definition, rational numbers are fractions. Root of 5. Yeah,
It's squared, it's irrational.
yeah, if that was a squared number, we'd be good.
It's not, it's irrational.
Yeah, this is irrational. If it was square root of 4, it'd come out as a 2, right? So that would be rational, integer, whole number, natural number. But since the 5 can't be square rooted, you'd get a decimal. That doesn't repeat. That makes it A. I think we said 6 too, right? You guys cool on 6? Any issues graphing it? Yeah, square root of 5 is irrational. Yeah, I'll move on to 7. All positive integers greater than 5. Graph the following on a number line. Okay. All right, well. See if I can do it with this pen. I don't know. Like I think that's the middle, right? Can't see from here.
I have no idea.
Probably. Oh, you know what? What we could do is just start at the number they're talking about. I think that'd be better. And it doesn't matter where we put it. Putting it here. So all positive integers greater than 5. So just put all the numbers after this. And just keep going and eventually just put dot dot because there's many numbers above 5, right? It's gonna keep going.
So just put dot dot after it.
Yeah, after like just write a few. And then put points above each one except 5. Because it said greater than 5, not equal to 5. That makes sense. You would put 1 here, 1 there. Can draw like this. That makes sense. Let me just keep going. Let's make it prettier than mine. If it said all numbers, then you would just kind of shade the whole thing. Or put like an arrow. But it didn't say fractions. It said positive integers. So I can only include the whole numbers after 5. So I'm not including 7.5, 8.5. You see what I'm saying? Only the whole numbers. All right. So what numbers for X would make this true? A true statement. For sure 10.4, right? What else? Yeah, both would be solutions. So negative 10.4 is equal to 10.4. Absolute value of 10.4 is also 10.4. So the X that they want as a solution set be written this way. That makes sense? Why these were chosen? There's nothing else that would satisfy this. Anything, any other X would make it a false statement. Okay. What about 9?
Same thing. Oh,
What did the definition say about absolute values?
That the absolute value makes it a positive.
And it's never,
It's never.
it's never negative. So this is saying that it's negative for some X. But that contradicts the statement, right? The definition. Because we said it's never negative. So how is this negative? That could happen. But since we don't have it, this is a false statement. There is no solution here.
there's no solution.
Not here, we have no solution. That makes sense. Like I can't pick a number, make it positive and somehow it's negative. It doesn't make sense. See what I mean? So that's weird. It's nonsense. If you think about it, but also straight up by definition, it's a violation of the statement. Never negative. Number 10. Determine if the value on the left is less than, greater than, or equal to the value on the right.
Greater than,
Basically, they want to know what symbol we put in there, right? Okay.
oh, yeah. What's this?
Well, let's deal with these absolute values first. That way we know for sure. Right now, I don't know. So we do know that absolute value makes it positive, but there's a minus waiting for you right there. Okay, so this guy becomes a 10. Okay, so now it's a little bit more obvious. Which one's smaller?
Okay, four.
Yeah. So less than is fine, but so is less than or equal. Technically, both are okay. There's an or statement, right? As long as one of them is true, you're good. So you see less than or equal, and it is in fact less than. That makes sense? Is that okay? All right. 11. What do you guys think? Is it true or false? Yeah, it is. It is. So how do you fix it? Yeah. So the true statement would be this direction. Okay. 12. Plot the set of integers. Okay, so again, they said integers, so that'll be whole numbers above 4. So if I put 4 here, I would start there forever. Right? But not 4. It also said absolute value. So what does that mean? But this, you'd have the same stuff over here, right? The negatives would be cool. But for example, you plug in -5, 4 would still be smaller. That makes sense. Yeah, I wrote that weird, but that okay? Strange right there. Okay. Right, the syllabus says we should go to 1.5 now, so let's do that. Dang. Oh, hold up. Yeah. I think I have 1.5.
You said 1.5. Then when you go back to the thing,
Here we go.
Jimmy at 8.5.
Says 1.
Oh.
Yeah. 1.5. Strange. Let me see here. I don't know if it's in the workbook. Hey, give me a second. Resume. Okay. Which one do I box here?
300. 310.
Yeah, the 10, right? Okay. And since you look to the right, it's bigger than 5. So what's the answer? 320. Okay, nothing crazy, right? Any questions on 1 through 4?
I'm gonna need
At the second number, if it's 5,
If it's a 5 or more, yeah, round up. Round each number to the nearest hundreds. Or some review questions just in case. So we'll probably need this later. Number 5. Which one do I box? Right.
We have to write it, it's like that.
Just write the answer below or box it right there. You don't have to write everything because you already have it. Yeah. Here, the page should look like this. I'm just doing this page. So here's the instruction on how you round. And these are the problems I'm doing right here. So on the front page, page 1, you'll see this. Okay. So I don't want you to have to write all that. You already have it. You're good. I don't want to write that either. Okay, so 6. You guys said this was what again? Okay. What about this one? Which one do I box? Do we box the one they're asking about? We look to the right. 9's pretty big, right? $700. What about this guy? Which one do I box? And it will be so whatever you're rounding, everything after will be kind of cut off. Okay. It just depends, depending on the number of the right will depend how we round the number in question, the placement in question. All right. What about, let's skip to 10, 11. Those look more interesting. $85,098. So which one's the hundreds place? So this is pretty big. What does this become? Yeah. Any issues with that? It's supposed to be. Well, we have it pretty much anywhere now nowadays. Walmart, Target, Amazon. But they do have an issue. Heat will make this erase. So if you leave this in your car, you're gonna have problems. That's why I scan these right away. Then I just wipe them away. So I like this Fusion notebook with these friction pens. But I made the mistake one day writing them in a normal spiral and just threw them in my trunk. Like I had all these complicated engineering notes. Took me like weeks to write, and they just started fading. Damn it. But yeah, if you do use them, make sure you know that. I should have known that. Hence friction, right? Creates heat. Erases with heat. $958. Okay. All right. I'm gonna box which one? What's gonna happen? Yeah. This one rounds up, which then rounds the next one, which then rounds the next one. Something that happens and it's weird. But that's okay.
That's good. Pain today or not?
What's up?
That's good.
Yeah,
Spirit?
it's Wednesday, every Wednesday.
What happens on Wednesdays?
Oh, we weren't going.
It's like a spirit day. I got you. Guess so. Yeah, I think that's the school colors, like a royal blue kind of. Yeah. Forgot about that. Sorry. It's been a while. You're right.
Oh my god.
Okay.
What? What? So what?
Alright, so I want you to work on, let's move on. You guys comfortable rounding?
I'll do it right.
We will in a sec. Why don't you do these in the book first? So number 20. See what they're asking? What happened there? That's weird. Here we go. The 20, so this is a adding technique, which is pretty obvious when you think about it. It says round each number to the place value of the leftmost digit. So you go all to the left and round that number. Once you do it, once they're all rounded, then you add them. So step 1 is add them using that estimation process, but then actually find the step 2 is actually find the number. That makes sense, the actual total. So right here, where's my little pen at?
You would do the 296 plus 182. I mean 128.
Yeah, you're gonna add those up. So step 2 is the actual answer. Step 1 is using rounding. Okay. So I underlined the ones you're gonna round. I didn't box it because I couldn't do it. But box the 2, the 1, the 6. Go to the right.
Add the all the.
Round them first and then add them. That's what they want you to do in step 1. Okay. This is what you guys did for the first step. You guys get 1100. What do you guys get for step two?
1,107.
1,107?
Yes.
Oh, can you give me one of the tissues actually?
Yeah, man.
Thank you.
Any more? Everyone else get 1,107? Everyone agree with this answer? So the rounding estimate's not that far off, right? It's pretty close. So it's just a technique to find a quick answer that's that has lost some accuracy. Okay. Anyway, so the homework will just have you go pick a number, and they'll tell you round to that number, that place value, I should say. And then after that, after a few of those, they'll have you do stuff like this, add and subtract. Do you have any questions or concerns with that, with those ideas? Does it seem okay? Okay. Just use the rest of the time to do your homework, so that way you can ask me if you get stuck. And I'll take roll in a second. So start 8.1 and 1.5. Yeah.
21 and 22.
21, 22. Estimate the difference, so that would be, the first one would be what, 300, right?
Yes.
And the other one.
125.
Okay, let me open it right now. Give me a sec. The other one, where's the other one?
Yeah.
Get 218. 218 for 22. Oh, sorry, 21.
Hey, that's kind of.
Yeah, I'm gonna open it right now. Give me a sec.
And a quiz. That looks like.
Is the, 0.1 open to?
It will be in about
How do you access?
2 minutes. It should be, I'll show you right now. Hold on.
Yeah, I got it.
You got it? $1.5. Alright, so I moved stuff from last week to Friday. Stuff from today is due on the 11th, which is next Monday. Okay. Could also work on 0.5. I'm sorry, 0.2.